I'm excited to be here today. I'm excited to share with you all a little bit of our journey around MLOps at Capital One, really talking about best practices around not only building a model, but then also shipping a model as a capability into production. So that's what we're going to be looking at here next. And now I have a blank screen. Can I have some help? Do this again? Oh, don't hit, yeah, wrong button. There you go. Don't hit pause. Very good. So what is MLOps? So it's an intense place to operate it. Let's start there, right? And so we've seen this today in the morning already with a number of different examples and use cases. So one that stuck in my mind was S&P sharing with us what it takes to just deliver a single use case. And imagine doing this several hundred times and having hundreds of models that you've pushed into production and that you're maintaining into production, and you've built this stack every time from scratch. What happens is that you have a really complex ecosystem for each one of these use cases, and you need to figure out how you want to scale it. So this is actually a relatively accurate depiction. I can go through every one of these boxes. I promise I'm not going to do this now. And they actually all have a function. And so if you check out the article, you can read all about that there. And it's also really challenging to get into this space as an engineer. How do you even become an ML engineer? Like, don't do what I did. Like, I spent 20 years figuring this out, and literally the whole industry started to develop as I was looking to develop my own journey. But imagine being a college graduate nowadays, coming out and trying to find your space in the middle of all of this. This Venn diagram has really evolved over the last couple of years and has grown to become more and more complex and more challenging with all these different areas of overlap. And it's become a proliferation of specializations and like niche roles that you can play. So how is one to create a career path in all of this is as challenging as creating the capabilities itself. So if you think of this in the context of Capital One, I'll give you an example of what MLOps actually looks like in terms of not just like creating a capability, but creating a model, but then also creating a capability to run that type of model in production, right? So a typical case at Capital One, and we'll have hundreds of different models doing all sorts of different things, but this is a typical one where you basically have like a credit card transaction and you want to detect whether that's fraudulent. Now that doesn't just require the ML model, but it requires you to do all the data pipelining and the feature engineering, and then making on the fly with low latency a decision of approving or declining a transaction, making sure that the customer has a great experience as they're using your product. So this is really where we're focusing on. And so if you think about this, you know, we've talked today a lot about really the life cycle of how to build machine learning models, how to secure success in your innovation cycle. And so ultimately you have this life cycle that you start entering where you have multiple stages that you iterate through and that you start looping over, where it's not just the model training part, but the model serving part. You know you're in trouble when these two parts of the Venn diagram do not overlap. That is the world that we came from, where you have an engineering team on the one side of the house and you have a data science team on the other side of the house. They don't talk with each other. They don't really have the same language that they use quite literally in terms of programming languages. And then you have to throw code over the wall, and you have all these challenges along the way. So the success with MLOps is really when you're able to kind of create that intersection in this Venn diagram and create an actual overlap. So, you know, now imagine doing this hundreds of times in a large cross-functional organization. Imagine the unique challenges that you're going to face in that space, and think about how you want to overcome that. That is what I do. It is a really exciting space to be in, as far as I'm concerned, because it requires you not just to ship one use case, but have a framework that allows hundreds of developers to come in, build their models, ship them out, and not have to reinvent the wheel as they're doing that. So this is where we've been focusing a lot of our time and trying to think through how to do this right. And so there's a number of inherent challenges that you'll face if you try to do MLOps well in a large organization. So, this is easy to do if in a smaller organization where you have more cross-functional capabilities, and you can just like pivot from one thing to the next, and you don't have to coordinate between larger teams that easily start to silo. And so then you end up with, like, in a large organization, quickly with tensions between objectives and goals between different parts of your organization, different lines of business pursuing different business objectives. And you need to think about how you bring all these capabilities together in a unified way. And so from a technology perspective, you'll quickly get into just the software development lifecycle and the continuous integration, the CI/CD loop that you need to establish, in addition to like the model development lifecycle that everyone in this room thinks about. So there's a couple of things that you want to do, and so really to be able to scale these capabilities out, it really comes down to standardizing them and automating them. And so this comes across a number of different dimensions. So I'm going to be focusing today with you on what we like to think of as a unified stack and how you create this in a large, complex organization. But then there's also other dimensions to this. So I'll be primarily spending time on the unified stack. You also want to think about things like your software developer kits and your libraries that you want to standardize. So that imagine that you have multiple lines of business in your organization, and everyone has like their little SDK that they've started to develop to make their life easy. And there's a brilliant thing over here, and there's another brilliant thing over there, and you want to think about how to bring that all together and make sure that you get good adoption across your enterprise. You want to be able to have your artifacts in a consistent manner. So if I think about that as an engineer, that basically means that I need to have like a service contract that is consistent from one model to another. That is a key aspect to being able to ship models at scale. So I cannot just keep having to reinvent my contract, and it's just going to introduce friction. And so if you think about an organization that invests in innovation and wants to leap ahead, you can do this once and twice. But if you have different engineering teams and different data science teams that are working on this, what's going to happen is that they're going to come up with different ways of solving for the same problem. And so then you're going to have to look at all of this and try to figure out what you're going to do about it. You want to incentivize reuse. That's a key thing, right? Like, I mean, there's this sounds maybe like a no-brainer to some of you. This is like how the whole open source software environment has developed over the last couple of decades. The key thing is that you need to figure out how to do this in an enterprise setting in addition to the open source software that you're also using. And then you need to figure out how you are actually supporting all these teams that are going to be using the framework that you're providing to them. So that's true platform engineering. That is really what it's going to take to scale this up. So let me get back to the unified stack and tell you a little bit more about how we're thinking about this. So at the end of the day, if you want to create this cohesive user experience on a model platform, I think there's three key ingredients that we've really started focusing on. So on the first thing, I was talking earlier already about like how you'll end up with like all these different capabilities that have been built across lines of business with different ways of solving the same problem of shipping a model, of building a model, of like automating that loop. So you need to figure out how to converge that. And so, I think today one of the key capabilities that we recommend to consider in that context is a Kubernetes native infrastructure that has a tooling that is easy to reuse and that allows you to really scale out your ML infrastructure in a way that will serve your customers' needs. You also want to make sure that you actually take advantage of all the enterprise capabilities that are out there already. So as a platform team, you also do not want to reinvent the wheel, just as much as your customers don't want to do that. So if you have a team already that's doing your continuous integrations and your CI/CD capabilities already, try to think about how to make that work for your model platform. Now that is not a trivial task because, especially in this ML space that we're all talking about, you have highly customized requirements, and as the model development lifecycle seems somewhat similar to the software development lifecycle, there is relevant differences. And you need to provision for those. You need to think about your requirements very closely there, and you need to work closely with your enterprise partners that already have those Rails set up for regular software applications. And I think that is a very deliberate choice that you want to make, as opposed to just go ahead and build your own version that works for your platform. Because if you choose doing that, you're just going to be stuck with the overhead for the life cycle of your platform. Think about the workloads and the developer lifecycle around that capability. That's a key thing, right? So if you think about like the cognitive load that it takes for a model developer, for an ML engineer to actually use these capabilities, it's a complex lifecycle. So you want to really think about how you create the right capabilities, the right developer tools to make that easy and streamlined. And so if you do this in a large organization with like all these different amazing innovations that have been coming out of all sorts of different departments of your large enterprise, you need to then figure out how you select the best-in-class capabilities and really bring that all together into one big stack. We find that using open source capabilities for this turns out to be a really good choice. This, again, maybe this is a no-brainer, but oftentimes we find ourselves in this situation where we want to figure out this build versus buy, our build versus buy option, and it seems for an initial step often easier to just go ahead and build this one component on your own. You need to, if you make that choice, you need to be very conscientious about it, because you're going to be carrying the cost of maintaining that capability over the life cycle of your platform. So that is where the challenges really start hitting in. And if it's a big enterprise level platform, you're not just going to deal with like a handful of capabilities. Just think of the chart that we started off with in the beginning. So you want to figure out how you create the right partnerships and leverage your its support across your enterprise capabilities. So the CI/CD team will be a key aspect there, a key partner on it, but there will be others there as well. So think, for instance, about your API gateways, the way that you're going to be publishing your models and be integrating them with other software capabilities across the enterprise. These are going to be key stakeholders that you want to partner with, and you want to figure out how you actually integrate your model platform capabilities with those other enterprise capabilities. And then to really kind of close that gap between these life cycles of model and software, you really also want to think about the model governance frameworks and how they integrate with your model developer lifecycle. I think it was earlier one of the presenters from T-Mobile that was talking about what it takes to document your model. I think I've heard somewhere in the back row someone say it was like 250 pages of documentation for one model that they were looking to ship. That sounds about right to me. So you want to figure out how you integrate the decisions process around the model governance together with your model development lifecycle, so that it becomes easier to ship your capabilities, ship your models as a service. And so then you want to prepare for future growth. So imagine you've done all these things and it's running and it's great and everyone loves it. What's going to happen is that everyone is going to start using it, and then you're going to have your second order problem, because now you're going to need to support all these users that are coming on board, and they might need some training. They might not exactly know how to use your SDK. They might have opinions about how this is supposed to run, and it might not exactly run the way that they envision it to run. So you need to be able to set your users up for success and make sure that you have a really compelling developer experience for your model developers, and maybe also for your ML engineers and your application engineers that are going to be using your platform capabilities. So what I'm starting to lay out here is that you're dealing with multiple persona. Besides the those primaries, you're also going to have like your model governance officer and a whole lot of other stakeholders that will be interacting with your platform capabilities. That's where challenges are going to come in and where you'll see friction, and you want to be sure that you have solutions in mind as you're starting to ship that. And so you basically want to incentivize those users to then also contribute back to your platform. So they have great ideas. How do you make sure that you don't just like shut the door and say, I'm sorry, we're not doing that today, but you invite them to actually bring those solutions to your platform. Figure out how they can contribute, figure out how you can then create a managed capability, a managed service out of what they have been offering, what they're proposing to. And you want to automate the production flows end to end, right? So that you can retrain your models and ship them then. Again, you know, if you think of the use cases that we've heard all day today about, it is hard enough to do this for one use case. Imagine doing that for hundreds of use cases. That's where, you know, if you think about the enterprise level challenges, if you think about like really hitting the next levels of maturity as, you know, on the AI ladder of success, those are the challenges that you're going to be facing. And so you want to then also create the right framework that when the next wave of technology is going to hit you, you're going to be ready for it and you're going to be able to do something about it. So today I'm talking about Kubernetes. A lot of us have today. Something else is going to be around the corner. And so you're either going to be ready to do something about that technology as it's going to come in, or your platform is going to turn into the legacy platform and you're going to have to figure out how to roll it off while something else is going to come up, right? So those are the challenges that you need to deal with and that you need to have answers for, that you at least need to have a plan. So we've had a lot of conversations with our users about this. We have a brilliant design team that really talks to our platform users about this. And listening to the voices of your users, especially like your advanced power users, is a key catalyst to really figure out how to correctly unify that stack. So I think especially in a highly regulated industry like finance, you will find that there is key differences between this model development lifecycle and a software development lifecycle that all revolves around production data. So whereas like a application engineer will be sitting in a dev environment and has like all freedom that he likes to prototype per solution, if you create a model development environment in a regulated and you want to use production data, you're going to have all sorts of compliance challenges. That's going to be hitting you right from the bat. And so you end up with an atypical progression pattern that's not like a standard software development lifecycle where you just go from dev to QA to prod. You need to think about how you're getting, you know, your model essentially through multiple production environments. And then these production environments typically look quite different. So that environment, you know, that Jupyter notebook thing that you use as a data scientist, and that environment that we're actually then using for serving your models, they look very different. So you need to, so as a user, the number one thing that we hear is, I want to serve on the same stack that I train my model. So making that happen is not a trivial task, right? Especially if you think about the developer experience that needs to go with this, right? Because if I'm going to set up a developer environment for a data scientist that looks like my serving environment, good luck. There's no notebook there. There is not your standard developer tools there. It's going to be a pretty hardcore stack that you'll need for these low latency services like we talked about earlier with the transaction pod model. Yes, exactly. This is the user story part of it. Great call out, absolutely. Yeah, so, you know, you basically need to figure out how to get through the CI/CD setup. You need to make sure that you have the right pipeline set up so that you get through that progression. And typically in a large enterprise, as I was touching on earlier, you'll have multiple stacks and multiple different setups for like how you build a model and train a model. You know, so you'll have one line of business that might be using Jupyter, another one might be using a commercial product that looks very similar to Jupyter, a third one likes to use like an IDE. You know, there's all sorts of different ways of setting that up and configuring it. And then on the serving side, the challenges that you have over there is that you kind of have a trailing release cycle, right? So if I have a unified stack, I will still have to work through my versions, right? So even if I have the same stack, I'm probably going to be updating my releases on the model development side before I start doing it on the model side. And I need to make sure that I keep that well in sync. And you need to figure out how you set this up so that as you kind of work your way through different versions, you have the right warranties and the right contracts set up with your users so that those legacy models that like one team may not be as willing or excited about moving over to your new version of your serving capabilities still has the support that they need while it's not creating overhead for your platform. So this is our view of how you can approach this, right? So essentially, talking of a user journey, I'm looking here like a 10-step process, right? So essentially, what we're converging towards and where we recommend as a best practice to consider is really thinking of like, using some sort of notebook environment, let's say Kubeflow, and you really start thinking about compiling a workflow orchestration, a DAG that you can run in a workflow orchestration engine. That's a good starting point for you to really just retrain your model in an automated way. But then in that, you need to figure out how you go from that step number 2 to your production environment that lights out, hands off, don't get to touch it, right? So the way to do that is then to really think about your continuous integration capabilities, right? And so this is kind of where the model development lifecycle starts overlapping with your software development lifecycle, where you're going to be using tools like GitHub. You need to educate your data scientists that might not feel that comfortable with it, how to navigate a pull request and how to navigate different branches in a code repository and how to basically trigger then the CI/CD cycles in the backend, right? So you want to have, you'll start in step 4 with your models with a custom CI pipeline that is spec'd for model pipelines. So double pipelines, right? And so in that, you're basically going to be building your artifacts that you can then ship into production. But you're not quite done yet, right? Because now, after you basically, now that where you are now is ready to ship, you can now go to production. So now you need to figure out how to get that done. So you end up with yet another set of pipelines that you need to standardize. And remember, we're trying to do this not just for one model, but for hundreds of different models, everything from transaction fraud to like chatbots and what have you. And so you need to be able to basically ship that out. You need to do, you'll end up with a whole set of additional validations that you need to run through to make sure that that artifact that you have there is good to go, and you have all the controls that you need at an enterprise level implemented and checked off before you ship. And at that point, you finally go then and deploy. You have a separate isolated model development environment. That's a primary production environment that we're talking about. And then you can like schedule, deploy, trigger your models as needed. So this is the way that we recommend to think of setting up that lifecycle in a way that you can standardize and iterate through the whole lifecycle without creating all these unnecessary, arbitrarily unique solutions along the way. While you're doing all of this, you better capture all the different model exhausts along the way. You want to make sure that you know which experiments were run, when the CI pipeline was kicked off, when all these different things run, and you need to be able to actually pick that up and introspect on it when it's time for that, so that you have it all at your fingertips when you need it. So I think the lesson learned in all of this is like MLOps is achievable in this, and you can do it at scale. If you want to do it right, you really want to be thoughtful of your solutions end to end. And so really what that means is like really focus on your standardizations, make sure that you have a strong software developer kit, that your users, that is provides a compelling developer experience for your users. And think about how you have your use cases and your stakeholders well set up so that they are willing and able to come on board. Like I think we had earlier a presenter talking about like even if you build a great capability, they might not come. You want to make sure that you don't get into the crickets and tumbleweeds, right? And you want to make sure that you track everything end to end so that from a compliance perspective, you have all the records that you're going to need to be able to demonstrate that no one has messed around with your model in production after you shipped it. So, doing this at Capital One, I think, I'm really excited about what we do because it really helps us to solve impactful and critical business problems. So if you're a big Capital One customer, if you use our customer experience capabilities like the chatbot, we've heard about many chatbots today. That's a type of capability that you want to be able to run, and you want to be able to seamlessly iterate through that life cycle without having to build everything from scratch every time. So that's what I got for us today. Come visit us on our career page if you're interested. Otherwise, I'm happy to take any questions.